All right, so let's look at the first example for lesson 7. Okay, what does it say? We've got two resistors that are placed in series with a 9-volt battery. Let's see. The potential drop over 1 is 1 volt. So I know from the difference between the potential from here to here, that's what this is a voltmeter measuring 1 volt. So this is basically how you measure something. You have these probes going down and finding little exposed areas of wire or metal or something like that where they can interact with the circuit, and in this case measure the change in the voltage over here. One of the things I'd prepared for the 930 class is how one of these things works, or how an old analog one of these things works. But didn't get to talk about it. It still was fun. But anyways, we know that there's a 1 volt drop here, we have a 9 volt here, and we want to figure out what the resistance is of this guy here. All right. So the question is what sort of things do we need? So for this guy, I think we need to do a little planning. Okay, so we need to figure out this resistance. Probably the way to do that is with Ohm's law. Delta V equals IR or equals IR. So we want to do that for R2. So we have to figure out what delta V is and what I is. Okay, so we need to figure out both of these. Let's see, how can we do that? Well, one thing we know about the current, this is a nice property of the current, is what goes in must come out. So whatever is going in here is coming out here. So I1 is equal to I2 is equal to I. So however we find the current, if we can find the current through, say, this guy here, which we may be able to do, then we can find the current that's going through here as well. And the other thing we need to do is we need to find this potential delta V, or basically delta V2. So the potential, in this case, has to add up this guy plus this guy is equal to this guy, right? So to come all the way around, it has to come back to the same number. So the difference between what's going on this side and this side is all powered by this battery. So it's 9 volts up, so it has to be 9 volts down to get back to the same level. And that means that the voltage drop from here and from here have to be the same. So since we only have 3 things, we should be able to find the potential as well. We should be able to find that electromotive force, which will be delta V1 plus delta V2. And we need delta V2 and the I2 to figure out what the R2 is. All right, so let's see. Why don't we start with, from the first resistor, finding the current and the voltage, right? Do this guy and this guy. Let's see, how would that work? Okay, so let's see, if we wanted to find I2, right? Or I1, no, well, I2 is equal to I1. So I2 is equal to I1. And then we could use Ohm's law to say, well, I1 is just delta V over R. Delta V1 is over R1. So that means we have 1 volt over 1 ohm, which is equal to 1 ampere. So all of the currents are 1 ampere. And how about delta V2? We just said the total is equal to the sum, strangely enough. Okay, and in that case, we know what the total is. It's 9 volts. This is where all the power is coming from. And then this guy, we said, has a measured 1 volt drop. So all we have to do to find delta V2 is subtract 9 volts, or 1 volt from 9 volts, which is equal to 8 volts. So I think we're doing okay with that. So now all we have to do to find this resistance is use Ohm's law once again. So now we've got R is equal to delta V. Now I have to divide over by I, right? So delta V over I. So R2 is equal to delta V2, which is 8 volts, over I2, which you just said was 1 amp. So that's going to be 8 ohms. All right, so that is the first problem. And basically what I did there was I said, okay, there are a few little properties I know about the circuit, right? I'm going to learn more soon, but these are some simple properties of the circuit. So I'm looking for this R, and I've got these other two things to look for. So I've got two different ways to find those different things. One used Ohm's law and the fact that the currents have to be the same. If you're going through in series like this, it has to be the same, otherwise you get a buildup, and you can't get a buildup because it's a wire, right? It's not like a bag or something that's increasing. If you have a buildup like that, it builds up straight capacitances if you accumulate charges, and that's very bad. So we just avoid those. And then for delta V2, we just use the fact that going down this potential, you have to use both of these guys. So then we're done. I guess then we take these and we put them into Ohm's law to find the resistance that we want, and we get it. Simple enough. All right. So that is example 1. Get to example 2 in just a moment.